So maybe you live very far away from the coast and far away from the ocean, or maybe you are living on an island and the ocean is all around you, or on a coast and you see the ocean in your front yard. But then you think the ocean is so big, you learn that it covers 70% of the surface area of the planet, and you think, we are living on land and doing all these greenhouse gas increase and trapping the thermal energy and global warming. Does that mean the ocean out there, which is so deep and so large, can also get affected by what we are doing? Well, kids, unfortunately, when we change winds and when we move the heat around, oceans, ocean currents, ocean temperatures, and ocean salt content and so on are all changing, and not only close to the coast but even in the middle and even at 3 kilometers down and so on. So this chapter 12, which is almost the last chapter of looking at the impacts of climate, is called Trouble at Sea. Oceans hold almost all our planet's water. Very little is outside of the planets. Of course, there are glaciers, as you know. They also hold a lot of carbon dioxide, because carbon dioxide dissolves very easily in water. Plus, ocean has some other ingredients like salt, not just the table salt that we eat, but other salts which make it easier for CO2 to dissolve and stay there, and that causes major consequences, which means if we affect the ocean in a way that its ability to hold, take down, and keep the CO2 is reduced, then more and more of the CO2 that we are producing will stay in the atmosphere, and this is where global warming is happening, in the sense of reducing the outgoing thermal energy and warming the atmosphere, and then of course the ocean warms and so on. When CO2, carbon dioxide, joins with seawater, it forms a kind of an acid. Okay, the Coke or any drink like Pepsi, Thumbs Up, or whatever the carbonated cola is in your country, it is actually an acid because it has CO2 dissolved in it, along with some other things like sugar and chemicals. A harsh chemical indeed is carbonic acid. When you dissolve CO2 into water, that changes the water's very nature. Sea creatures such as certain clams and oysters that make their own shells are going to be affected by acidification, is what it is called, when we dissolve more and more CO2 into the water. The shells of these creatures help them to protect themselves against predators. If it is hiding an oyster or a clam and so on is hiding inside, the predator cannot come and just chew it off unless it has very strong teeth, or it knows how to break it open and eat it, right? But with more acid in the water, the shells grow weak. There are some chemical equations, chemistry equations, chemical reactions involved in producing these shells, and why the production of those shells to protect themselves depends on the acidity or the pH. You may know, you are maybe old enough to know what the pH scale is. It's related to hydrogen log minus hydrogen and so on and so forth, minus log hydrogen. So they can dissolve if the water becomes more and more acidic with more and more CO2. Young clams and oysters tend to die off when acidity gets very high. Entire species are at risk, and other beautiful thing that we'll look at in another section called the corals. If you don't know what corals are, you ask your parents, brothers, sisters, teachers, or Google if you're old enough and see the beautiful image of corals. Corals also build shells. Anything that builds these calcium carbonate or chalk shells can dissolve when the pH reduces or the waters become more acidic. Okay, The krill in the Antarctic is an example. In the warming Antarctic Ocean, krill, which looks like a shrimp and is standing like this because if it doesn't swim all the time, it sinks like a rock, and it can stay in the water by swimming, and it makes it this way. Okay, so it's a tiny shrimp like creature, and they are in danger. They mostly occur in the southern ocean, but they are everywhere. Their life cycle is tied to water temperatures, CO2 levels, or the pH of the seawater, and how much seawater they raise. With these factors changing, survival is difficult for these krill. Although climate change may not be the only cause, krill populations have dropped by 70 to 80%. So this is where you see why we say although climate change may not be the only cause, because we can observe, we can measure, we can see that krill numbers have dropped by 70 to 80% in some places, and then you have to say, what is causing this? Is this natural or is this human-made cause? We know that humans are producing CO2, and if CO2 dissolves into the water and its pH becomes less and less and its temperatures warm more and more, then krill are going to be negatively affected. So definitely we are contributing to the drop in the number, but we have to figure out how much of it is natural, right? So how does it work? Naturally, what things are happening can get worse because of global warming. It's like you are not feeling so great, you have a little fever, and then you fall down and it hurts more and you're feeling miserable. I'm just using an example, but you can think of how things can get worse. You may get a fever because of natural causes, but falling down is not so natural, and that may make you hurt more. Krill are a major food source for whales, seals, penguins, fish, and seabirds, some of which are food sources for other sea creatures. In other words, seals, penguins, fish, and seabirds are eaten by other creatures. So there is a food web, a food chain, right? Without krill, the entire ecosystem is in danger. Some of these whales, they come all the way from the Arctic Circle, very far north, across the equator into the Southern Ocean to eat krill for various reasons. Okay, without going into the details, they come this far, and krill is reducing in number. That's going to affect the whales, and if whales are eating something, that's going to be affected, and so on and so forth. The entire ecosystem, made up of phytoplankton photosynthesizing, zooplankton eating the phytoplankton, and zooplankton being eaten by little fish, bigger fish, whales, and so on. Everybody is going to be affected. The same holds for bright multicolored coral and coral reefs, because coral reefs also begin to melt when acidity goes up. Coral polyps, they are called polyps. These are the hard shells that are sea animals similar to jellyfish found in tropical waters. As coral polyps grow, they produce limestone or calcium carbonate, for those who know chemistry. These create a hard coral skeleton which grows and grows like a tree. Eventually a coral reef builds up, and the Great Barrier Reef, which is off the coast of Australia in the warm waters of western tropical Pacific, has almost 3,000 reefs and hundreds of small reef islands. It teems with sea life, which means it's full of sea life. Corals are like the rainforests of the ocean. Sponges, plants, and schools of colored fish swimming in and out of these hiding spots. Everything gets recycled. There are symbiotic relations between the coral, the phytoplankton that live on them, the zooplankton, the fish, and so on and so forth. But these reefs are in danger. Water chemistry is changing, and so is the water temperature. Over the last 135 years, the global sea surface temperature has gone up by 1.1 degree Fahrenheit, but this number is by now different because the book was written a few years ago. Like most climate factors, a small change can make a big difference, and studies show that the most warming has happened most recently, which means ocean is not only warming, it is warming faster and faster. So the warming is accelerating, and the warming is going deeper and deeper. It's not anymore just in the top 100 meters or 200 meters or even 700 meters. Now you can find warming waters even down to 2 kilometers. This is called a trend because, as we discussed in the beginning, temperatures are warming and warming and warming, and that is a trend. So we'll come back and discuss a bit more about this topic and probably conclude the chapter with the second podcast. But the main point is that you may be far away from the oceans and the ocean is big, but our influence is reaching the breadth of the ocean and the depth of the oceans and affecting everything that lives in the ocean, as well as its temperature, its chemistry and its biology, and so on and so forth. Okay, we'll come back and discuss some more about trouble at sea. See you in the next podcast then, kids.